So for this week, we are going to focus on what's called Gaussian elimination. So Gaussian elimination has two different stopping points, essentially. We have Gauss elimination with back substitution, and then we also have what's called Gauss-Jordan elimination. They're the same thing, more or less, we just stop at different points. Both of them are going to start out with our augmented matrix. So we have A on this side and B on this side. I'm going to make up an A and make up a B. 1, 3, 2, negative 1, 7, 9, 2, negative 4, 5, and then 10, 15, 20. Okay, so let's say this is our augmented matrix. Our goal is to do our elimination steps. To do those 3 row operations, we can multiply a row by a non-zero constant, we can rearrange our rows however we want, and also do our elimination step, where we're going to replace a row by adding it to some non-zero value or to some other row. So our goal is to do those 3 steps in order to get what's called row echelon form. Row echelon form is defined by these characteristics. Pivots are considered the first non-zero entry in their row. So this would be a pivot, this would be a pivot, this would be a pivot. Right now, they're not very exciting. But pivots, so the first non-zero entry is going to be lies to the right of the pivot in the row above it. So we're going to get this staircase pattern. And then below each pivot is going to be a column of zeros, and then 0 rows come at the bottom. So my goal is to make this matrix look something like this. Number, 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 0, number, 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 0, 0, number, number. So this would be my pivot location. Notice this staircase pattern. Each pivot below it is to the right. Below this pivot is zeros, below this pivot is zeros, below this pivot is zeros. This is an example. This is a classic example of what's called row echelon form. There are other forms, and we will see a couple other ways this might be demonstrated as we go along. So there's multiple ways to do these row operations for this matrix. So you might get a different row echelon form than other students, that's fine. But essentially, here's our steps. So first we want to write the augmented matrix of the system. Check, did that. Then we're going to use our elementary row operations to transform the augmented matrix into my row echelon form. So for example, I can replace this second row. So I'm going to replace row 2 by saying row 2 plus row 1. So row 1 isn't going to change. I'm only changing row 2. Row 3 doesn't change. And then I can replace row 2 by saying negative 1 plus 1, which is 0. 7 plus 3, which is 10. 9 plus 2, which is 11. And 10 plus 15, which is 25. So we can see I have a 0 here, which is what I want. I want it to end up looking something like this, where I have my lower triangle of zeros. So then I'll just repeat. Keep going, repeat using elementary row operations to get zeros in more or less this lower triangle. Once I have that, then I can rewrite my systems of equations. I can rewrite my system. This system is going to be 0x plus 0y plus something z, and z equals something. So I can easily solve for my third unknown with this last equation. This second equation here, this middle one, would be 0x plus something y plus something z equals a different b. But I know z from this one, so I can go ahead and plug in z from there, solve for y. Once I know y and z, I can go ahead and plug into this first top one and solve for x. That process is called back substitution, where I solve for my last unknown with my last equation and work my way up. Some tips and tricks: eliminate the numbers in the first column. So eliminate these numbers first. You don't have to, but eliminate those ones first. And then eliminate the second column, the numbers below in the second column, and then the third column, etc. And we'll see multiple examples of this. So for Gauss elimination, I'm going to stop there, and it's called row echelon form.